David, I think a lot of you will have met, is one of the team that's producing this book, and he's written a lot of the interactive things that you've been interacting with. But also, in some of the earlier research work that David did, he did a lot of work on computer vision. The computer vision chapter is in a very early state of development, it's probably the right way to put it.
Under construction.
Under construction, yeah. But we'll hopefully have something there by the end of the holidays. But what I've asked David to do is just give you a very quick tour of what we mean by computer vision. In talks yesterday, I think we saw a few applications, but these are the kind of, remember we're looking for key areas, for the problems that are addressed by the area that students might actually interact with. But I'll hand over to David, thank you.
Thank you, Tim. Now, I'm probably going to be doing a relatively non-in-depth talk on this, so on the other hand, if there is anything that you'd like a bit more explanation of, please let me know. So when we're talking about computer vision, what we're actually asking is how can we make a computer understand its environment, and what kind of features can the computer recognize about the outside world. Sometimes this is done from just a static image like a camera image, but sometimes it's from video or other things as well. If you're thinking about the kinds of things that a computer can recognize, or it would be nice if a computer can recognize, can anyone give me any examples of something they think it would be good if a computer could understand about the world around it?
Facial recognition?
Facial recognition, yes. Any other thoughts?
Pedestrians, so that the automatic car doesn't run them down.
Yes, pedestrians, so that all yes.
Whether it's me trying to access my bank account or somebody else.
Whether it's you trying to access your bank account or someone else, biometrics, yes, that's very important. So, moving on a bit, we've got some general features. There are more of them out there, of course. But things like colour, or shapes that it can see, or understanding lighting, if there's a difference in light levels and so forth. Understanding when things are moving and how fast they're moving, and recognising certain patterns are relatively common areas where people can start to approach computer vision from. One thing that we're going to try out here at the moment is an edge detector. This will allow us to extract some straight lines from images that can then be possibly passed on to another program or be used to detect certain shapes in the environment. So we're going to try loading this thing up. It's this one here. Now for some very basic images, hopefully this is going to load. There we go. The one on the left is the source image, and the one on the right is showing that it's figured out that there's a square and a triangle. That's pretty boring. So let's try doing something a little bit more interesting, like there's an elephant. So with this one here, as you can see, it's picked up some of the strong edges where the elephant's ear are and so forth, but it hasn't picked up some of these things here. Now you can get it to pick up some of those other interesting shapes, but you have to play around with the settings and try and work out good ways of modelling those things. It's one of those things that computer scientists do. This one here is a photo that I took a few days ago. And as you can see here, we've got a nice rainbow, but it can't detect it. We can detect the straight lines from the roof there, and it can detect some of these straight lines from the stop sign and the signs down here and so forth. It can even detect a tree. But because the rainbow isn't a strong enough edge, it's just not showing up. So there are certainly limitations to these things that you can possibly explore with your students in terms of what you can and can't detect using this kind of method. So back to our slideshow. One project that they're doing through the headland at Cadbury is using robots to prune vines. I mean, the traditional method here, you have someone who has probably been trained for quite some time to learn what the best things are to trim and what the best things are to let grow in terms of growing vines for winemaking. Now, they're working on robots that will try and do a good job of doing the same kind of thing. And the images that you can see down the bottom, we have the view of what the robot has seen in terms of extracting the vines from whatever the background is. And then in this one here, it's trying to divide them up into little segments so it can try and work out if, for instance, this is a straight line going through here, or whether it actually comes from this place, for example. It's a little bit hard to tell from a static image just what's connected where if you're just looking straight at it, so they have a few other techniques that they can use for those kinds of things.
What happens when there's wires there?
When there's wires
By
there,
itself, but surely you see the straight lines as wires?
if there are wires there as well, it's actually quite good at detecting those because they're nice straight lines, they're a different colour, so those can be easily filtered out. And when it's looking for the stems themselves, they're usually a brown colour, they have certain other characteristics. But you have to have a program that's clever enough to know to ignore the wires, because otherwise it could cut those tips. Now, face recognition. Here's one I prepared earlier. You'll see some of the people here. I mean, if it's a standard face looking straight on, there are some techniques that are quite robust with being able to tell this is a face, this is here.
Is that a good-looking face recognition software?
That's probably something that's a little bit more artistic in this case. But if you notice Ren's face here, for example, he's looking down and away from the camera, and it's a lot harder to detect that kind of face.
There's got to be some reason why a square was chosen as a symbol as well.
That's But you'll notice that some people's faces are sort of behind other faces or obscured partially and so forth. And so they may be hard to pick up unless you have some other kind of features that you're looking for. Now this is something that Tim came across when he was in China. Tim doesn't read Chinese particularly well. So this is an app for his phone that will allow him to look at this through the camera, and then it will pick up these characters here and work out what it is that they say and translate them for him. Now this character here, or these two characters here, are talking about smoking, to smoke, to have a smoke, etc. On the other hand, knowing that is all well and good, but these ones next to them say, please don't. So you have to be careful to understand what you're picking up and the context of it as well. And these things, it's also getting to the stage where they can work in real time as well. I mean, in the old days, you would take a photo and then it would work for a while and work out exactly what these things are. But our algorithms and our processors are fast enough that you can do these kinds of things real time. This one is an interesting one. This is stitching a bunch of images together. So you have a number of camera images that were taken in around about the same place. And the algorithm is identifying features that are common between photos that are next to each other. And it's working out from the common features where they are and seeing if it can make a panorama out of each of them. Now it isn't working very well in some areas, so this piece of white water here, for example, is the same as this piece here, but it hasn't quite matched them up. And with this one here, we've got a nice panoramic image of, I believe it's a New Zealand Britain. And because it hasn't been a static scene, some of these people have moved in between pictures, so you can see ghost images of them and so forth there as well. So there are certain features that will just stitch together marvellously, but you can see around the edges some of the places that it breaks too. You see quite a lot of these days, especially with mobile scanners and so forth out there. This is demonstrating pattern recognition. So if you have one of these, which is just nicely printed on a bright white thing, it's quite easy to pick it up. But if it's off on an angle and the lighting conditions aren't exactly right, and that kind of thing, you have to do a few more techniques to try and get the image out of this. You'll also notice that this is the top of the image here, but that's the top of the image there as well, so it has to take into account that it's being rotated and all those kinds of things. And in fact, if I get out my phone, I might even be able to scan this, see what it says.
So this is the evaluation. How far away can it scan from?
If I go.
It says, never going to give you up, never going to let you down. So yes, you can put all sorts of things into these QR codes. It doesn't necessarily have to be a website or something like that. It can just be some text data as well. And the website that you've got there actually allows you to go to there and make a QR code for whatever message that you might want to put on there. Now this is getting a lot fancier. This is something that we did as a project with the Hitland for the Lord of the Rings motion picture exhibition. And we were trying to get real-time motion capture working. Now this is probably not going to be the kind of thing that you're going to be doing with students in class, but this is something that can give you an appreciation of how all the various bits fit together. So we had this man here, who's David Seckinger. He's standing in front of a camera with two cameras so that it can tell from the stereo vision how far away he is. And it's also picking up these brightly coloured sword and shield prop things that he's holding in his hands. Doing some colour tracking on there. It goes, this is the lightest yellow blob, this is the lightest red blob, and I can figure out where the sword and shield are. It's also extracting his silhouette from the background and working out generally where it thinks the skeleton is, so that it can then use that to drive this Gondorian soldier. So he can sit there and do sword moves and so forth, and this thing will move along with him. Now it's not as good as Wetter's version with Gollum wearing his neoprene suit with all the little dots all over it, but it's enough to illustrate generally what's happening. And we'll get on to making those things better as time progresses, I'm sure. There's a dancing hawk. Now just before we head off, I'll also just show a couple of little demos that we have that will allow you to see some of these algorithms working in real time. So this is edge detection using a Laplacian filter, and you can see me and the various things behind me, and you can see how it's extracting all of the various edges from those things. My glasses show up quite nicely, not so much the beard. And where else are we? This one here is detecting my face. My face is the strongest one there. It's sometimes getting a couple of other circles elsewhere just from noise in the background. But you can tell over time that this one is most likely to be where the face is, because it's the circle that isn't changing so much.
Yeah, that one's a circle where the other one was a square.
Yes. And then we have other fancy things like this one. Now, this isn't doing anything particularly interesting right now, but if I do this to it, then suddenly it's got a whole bunch of points that it's tracking, and it will show you some movement within the scene. And if I want to, I can also do this. So you can see me moving. So you can see that tracking of all the features and so forth is one of those useful things that they can try out for themselves and see how well it works.
And this would substitute for Gollum's suit?
Not quite as good as that kind of thing, but over time perhaps we can. That's a whole lot cheaper, yes.
Instead of having to attach special detectors to the
Well,
they're now picking them out automatically.
Yes. I mean, when our computer vision teacher Richard Green was doing his PhD work, he was working on extracting pictures of people doing gymnastics moves. And unfortunately it wasn't being processed in frames per second so much as 10 seconds per frame. But as our techniques are getting better and as our computers are getting better, then we can start to do some of that kind of thing in real time. Okay, that's it from me.
Well, actually, maybe I'll just comment. So, in terms of what we're planning for the book, it would probably have a lot of those examples, but in particular, we'd want to try and set up those programs so it just says, look, just download this, turn off this firewall, fix this thing here, whatever it takes, and your students can do that. And then again, the standard is, what are the techniques? Well, there was an edge detection filter. That's more jargon that your students will be aware of, that people who do vision use edge detection. They can actually have a camera, go around, take shots of, like last night we were looking at wheelchairs detecting the edge of a door, but it might be detecting whether how many faces are in a room or something like that. And again, no programming, but just evaluate it. Like, how far away could a face be before this filter stops working? What happens if you put a false moustache on or a hat or something like that? Does it
still work if you hold up a computer printout of a photo of yourself? That kind of thing.
Yeah, which has interesting implications for security, right?
Definitely.
And yeah, so does it give you an idea of the sort of evaluations and demonstrations that students could do? And the goal is they come away going, oh, computer vision, that's really useful because you could do this, and hopefully their imaginations will come up with things that we never thought of that would be useful for it. Yeah.
Just a comment by way of observation, that a lot of what you talked about for this standard in computer science seems to involve scientific method.
Yes.
But that's not explicitly stated in the standard. I'm wondering if there is that intentional? I mean, physics or science has level 3 scientific method assessment.
Yeah.
Why is it not part of this standard?
On these.
In the comment on the scientific method, there's actually not a lot of the standard scientific method in this. There is some of it, but this is much more engineering. This is typically computer science and software engineering are much more in that engineering sphere. Here's a problem, how do we solve it? How can I create something that solves it? So all these things, wonderful things we've just seen. But wasn't it with physics, where the physicists are trying to see what's out there in the world, and there's all sorts of standard scientific method for measuring what's out there, determining whether some theory about the world is true. This stuff's actually different from that, because we're making new stuff.
I'm just thinking in terms of what the students are looking at in terms of experimenting. What I'm hearing here is test, edge detection, test face detection, how far away. There's independent variables, there's experimentation, method, right up.
And so it is that there are strong connections there between evaluation and scientific experimenting. Yes, they merge into each other, they share a lot. If you get into the scientific aspect of the testing and the statistical stuff, we're actually going to send your students off.
But I think what you're saying is that and in particular, if they have done science experiments, they'll probably be. I mean, in the end, it's about communication. Can they communicate to you that this method works this well? Scientific method is it's a standard for communication that scientists have used for a long time, and it's a very rigid, way of doing things. Whereas with this, it's a lot more like, can you convince the examiner that you kind of get the point of it, and so on. So the standard's a little lower. If they did a full scientific experiment with everything, then I think they would probably nail the standard. At least the evaluation part of it. Of course, they still need to articulate what's the practical application of this and things like that.
I guess that's also one of the problems of having a modular system, is that you can't necessarily guarantee that students will have a strong grounding in the scientific method before they come into the standard. And so, if you can't necessarily guarantee that, trying to enforce it is going to be having a lot of your students not able to come up to that standard well.
Nor is that the key focus. It's understanding what are these ideas, what are the key algorithms, key approaches, and what are their limitations. The testing is just one aspect of it. It's important, but it's only one part.
Any other questions about the vision or pretty good? Great. By the way, you can probably tell we're actually enjoying working on this as much as anyone else, because we talk about it a lot and think about it a lot, but we we don't actually get to play with it a lot. So it's
By
pretty
the way, 5 years ago, it was really hard to do this stuff in the classroom. But today, with the Connect box particularly, you can now get into your classroom cheaply computer vision hardware and software that will let you explore all sorts of stuff. That would make my master's thesis so much easier. Right, there is magic happening in this area right now which will make it easier for you.
Yeah. Okay, now, on the schedule, I was going to talk about tractability a bit. But I actually ended up talking about that the other day, so I don't know if I'll labour that. So, just the main thing was complexity and tractability, which is the sixth topic that we haven't talked about a whole lot. We had the travelling salesman problem, and I've got the black screen of death problem.